Hi everyone, today we're going to be talking about how to solve quadratics with the quadratic formula. So we've talked about a couple of different ways that we can solve quadratics, and this is one of the last, in fact the last way that we're going to talk about. This way with the quadratic formula will always work no matter what. Sometimes it might be easier than other times, but it will always work. Whether your solutions are real, whether they're imaginary, it's always going to work. So in order for you to be able to solve with a quadratic formula, the original equation or the equation needs to be set up in standard form. We've talked about what standard form is, but it's right up top here. It's ax squared plus bx plus c is equal to 0, where everything is set equal to 0. Everything's on one side of the equation. And your a is in front of the x squared, your b is in front of the x, and your c is the constant term with no x. It doesn't necessarily, a, b, and c are all numbers, so it doesn't have to be any certain numbers, but they just have to be set up in this order with the x squared term first, then the x, and then the constant term last. And if it's set up in this standard form, then we can use the quadratic formula. The quadratic formula is underneath that standard form. It's x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now this is something that you will likely want to memorize. It's not something that you'll be required to memorize, but something that you'll do so often and so frequently that you'll most likely memorize it. So notice on this formula you have a plus or minus right here. What that tells me, it's not like you get to choose plus or minus, it's that you have to do both. We're going to have two equations. I could write this as two equations, one with a plus right there and then one with a minus right there. Remember, on all of our other videos that we've talked about this lesson, they've had two answers. And so this is where we get our two answers from. One answer has the plus there and then one answer has the minus there. Okay, so let's get started with the first example and I'll show you how to work with this formula. So the first example is 2x squared plus 9x plus 7 is equal to 0. So the first thing I'm going to do is figure out what my a, b, and c are. In this case, it's already set up in standard form where you have the x squared term, then the x term, then the constant term. And so that tells me that a is equal to the number in front of x squared, which is 2. B is equal to the number in front of x, which is 9, and then c is the constant number, which is 7. So these are my three numbers. Now I'm going to plug them into my formula. So when I plug them into my formula, I'm going to have x equals, which is like what I'm trying to solve for, then negative b. So when I replace the letters in my formula with numbers, I'm always going to put them in parentheses. Now, normally the parentheses don't necessarily matter too much, but it's going to be really important that you do this, mostly so that when you plug them into a calculator, the calculator recognizes what you want to do. So when I replace b, I'm going to put 9, because we know that b is equal to 9, and then plus minus the square root b squared, so I'm going to say 9 squared minus 4 times your a, which is 2, times your c, which is 7, and then that's all over 2 times your a, which is 2. Now, here's the deal. Potentially, we could plug this into a calculator, like straight through, and it would give us an answer. The way that I want you to try and do this, mostly because some of your answers might be imaginary, I want you to simplify this a little bit by hand. You can use your calculator for sure, but we're going to simplify it in chunks. So when I say simplify in chunks, I mean, we're going to say, well, this not negative 9, I can just take the parentheses away and make it negative 9, plus or minus the square root. Now I can plug in like 9 squared minus 4 times 2 times 7 into my calculator, and I get 25. So the whole square root turns into square root 25 over 2 times 2, which is 4. Okay, well, we know the square root of 25. We can plug that into a calculator. The square root of 25 is 5. We can also do the factor tree for it. So that would give me 5 and 5. So I'm going to get negative 9 plus or minus 5 divided by 4. So once we get to here, we can write it as two separate equations. We can say negative 9 plus 5 divided by 4, and then negative 9 minus 5 divided by 4. and plug those in. When I do negative 9 plus 5 divided by 4, I get negative 1. And then when I do negative 9 minus 5 divided by 4, I get negative 14 over 4, which is the same thing as negative 3.5. So these are my two answers. That's like what the quadratic formula gives me. Awesome, perfect. And they actually ended up being pretty numbers. Sometimes you don't get super pretty numbers because of the square root, but these ones turned out really pretty. Okay, let's look at the second example. And the second example is 3x squared minus 2x minus 9 is equal to 12. So the first step here is to get it into standard form or set equal to 0. To get it set equal to 0, I'm going to subtract 12 from each side. And when I subtract 12, I'm going to subtract it from the constant term because those two things are like terms. So you'd get 3x squared minus 2x minus 21, because negative 9 minus 12 is negative 21, is equal to 0. Now that we're in standard form, we can figure out what our a, b, and c are. So our a is equal to 3. Our b is equal to negative 2. So it keeps the sign, and then c is equal to negative 21. Make sure that if it's got a negative in front of it, it stays negative when you label your a, b, and c. All right, now I'm going to just rewrite the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now let's plug in what we know. So it's going to be negative b, which is b is negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times your a, which is 3, times your c, which is negative 21, all over 2 times your a, which is 3. Now we're going to simplify that. So negative 2, when you have those two negatives right next to each other, it makes it a positive 2, plus or minus the square root. Now I can plug this in. I've got negative 2 squared minus 4 times 3 times negative 21, which gives me 256, all over 2 times 3, which is 6. So the square root of 256 is 16. I can plug that into a calculator, which means that my two equations would be 2 plus 16 over 6, and then 2 minus 16 over 6. So 2 plus 16 over 6 is 18 over 6, which gives me 3. 2 minus 16 over 6 is negative 14 divided by 6, which is negative 2.3. Repeating, we can just say it's negative 2.3. So those are my two answers there. All right, let's go to the third example. So the third example is 4x squared minus 8x is equal to 14. So once again, we've got to get it into standard form. The way I'm going to get it into standard form here is by moving the 14 over. And the way I'm going to move 14 over is by subtracting it from each side. Now, 14 doesn't have a like term on the left side because 14 doesn't have an x and everything else has an x. So we just kind of tack it on to the end. So you have 4x squared minus 8x minus 14 is equal to 0. Now that it's in standard form, we can put it in, we can label our a, b's, and c's. So we'd have a is equal to 4, b is equal to negative 8, and c is equal to negative 14. I'm going to write that quadratic formula once again. So we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's plug these numbers in. We'd have negative b, which is negative 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times your a, which is 4, times your c, which is negative 14, all over 2 times your a, which is 4. Now we're going to start simplifying this. So negative 8, those two negatives make a positive, so we've got positive 8 plus or minus the square root of negative 8 squared minus 4 times negative 14 is 288. So notice when I plug this into a calculator, I'm not plugging the square root in, I'm just plugging what's inside the square root in. While the last two examples had whole numbers as square roots, like when you plug them in as a whole, it'll give you a square root. Or when you plug it in with the square root, it would give you a whole number, sorry. This one will not, I don't believe it will give you a whole number, so that's why we've got to leave it like this. Then we're going to divide that by 2 times 4, which is 8. Now I'm going to show you how to simplify this square root. It won't turn into a whole number. You could try and plug it in. When I plug in square root 288, it gives me 16.97056.275. It's a never-ending decimal though, so we can't just round it. I'm going to show you how to simplify the square root, but I will also tell you that I will take decimal answers. So when we simplify the square root, what we're going to do is find two numbers that multiply to be 288, and this can be any two numbers. So I'm going to just pick 2. I'm going to divide by 2. So when I divide by 2, I get 144. So 144 times 2 is 288. Now I'm going to split up the 144. The 144 is the same thing as 12 times 12. I would potentially split up the 2. I would continue to split up until I couldn't split up anymore. But the 2 I can't split up. 2 is just 2 times 1, so I can't split that up. But I could continue to split up these 12s. I could do 3 times 4 on each of them. But let me show you this. When we're simplifying square roots, the goal is to find a pair. And look, there's already a pair of 12s. And when I find the pair of 12s, what I'm going to do is pull it on the outside of the square root. And then the thing that I didn't circle, which is that 2, stays on the inside of the square root. So I can rewrite this as 8 plus or minus 12 because of that pair of 12s, square root 2, because that 2 didn't have a pair, over 8. Now, let me tell you this. We are going to learn this way better in the next lesson. So once again, I will take the decimal answers, but if you want to start trying to learn how to simplify radicals, you're more than welcome to. So the last thing I can do is notice that all the numbers on the outside of the square root are divisible by 4. So I can divide everything by 4, which would give me 2 plus or minus 3 square root 2 over 2. This would be my final answer if I left it in square root form. Now, once again, I told you we could use decimals. So if this whole situation freaks you out, you can take it from this point right there and just say 8 plus the square root of 288 over 8 and 8 minus the square root of 288 over 8, which when I plug that in, let's see, 8 plus the square root of 288 divided by 8 would give me 3.12 approximately. And then when I do 8 minus the square root of 288 divided by 8, I get negative 1.12. So these are just decimal versions or approximations of the answer. Whether you answer as a decimal or whether you answer as the radical, either way totally works. Okay, let's talk about that last example. So example number 4 is 6x squared plus 12 equals negative 2x. Once again, we want to get this into standard form. So I'm going to move the 2x over by adding 2x to each side. The 2x doesn't have terms though on that left side, so we're going to put it into standard form, which means the 2x goes right in the middle because it's got the 1x there. So it should look something like this. Now that it's in standard form, we can label our A's, B's, and C's. So our A is 6, our B is 2, and our C is 12. It's really important that you get it into standard form before you label your A, B, and C, mostly so that your signs are right. Notice that the 2 started as negative but went to positive when I put it into standard form. So you want to make sure that it's set up in standard form first so that your signs are right. Okay, now let me write the quadratic formula again. We've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's plug some stuff in. We got negative b, which b is 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times a, which is 6, times c, which is 12, all over 2 times a, which is 6. Okay, once again, we're going to simplify by hand. So I'm going to have x is equal to negative 2 plus or minus the square root of 2. So I'm plugging what's inside the square root into my calculator. So 2 squared minus 4 times 6 times 12 gives me negative 284. Excuse me. And that's all divided by 2 times 6, which is 12. Now, if you remember from the last lesson, we cannot have negatives underneath the square root. When I have a negative underneath the square root, it gives me a imaginary number, which is not happy. So what we're going to do is we're going to first change this so that it doesn't have a negative under the square root. We're changing it to an imaginary number. I can rewrite it as negative 2 plus or minus I square root 284 over 12. And then I'm going to plug in the square root of 284 into my calculator. It gives me a really long never-ending decimal, so I know that we can't necessarily just plug it into a calculator. We should simplify it. So I'm going to start simplifying it by dividing by 2. Oh, let's say 284 divided by 2 gives me, so I'd have 2 and 142. Now I'm going to, the 2 can't be split up, but I can split up the 142 to 2 and 71. And then 71 is a prime number. Even though it's a big number, I still can't split it up. And so we're kind of done there, but we do have a pair of 2's, and so that 2 gets popped out of the square root and the 71 stays in, which means I can rewrite this as negative 2 plus or minus 2 from the pair of 2's. I square root 71, because the 71 didn't have a pair, over 12. And notice everything on the outside of the square root is divisible by 2, so I can divide everything by 2, which gives me negative 1 plus or minus I square root 71 over 6. Now, this is my simplified radical answer. If you are really nervous about doing the simplification of radicals, you could start from right here. Now, your answer still has to have I in it. It's not going to be this pretty just decimal number, but what we can do is say, well, the square root of 284 is approximately 16.85. So I could write it as negative 2 plus or minus 16.85 I over 12. And then I can divide each chunk by 12. So negative 2 divided by 12 gives me 1/6, which is 0.167. And then it would be plus or minus the 16.85 divided by 12, which gives me 1.40. And then that has to have an I on it. We can't combine those because one has an I on it and one doesn't. But potentially we could write it like this. And you could even write it separately. So you could say like 0.167 plus 1.40i, and then 0.167 minus 1.40i. Normally we would just leave it in radical form, but if you get really nervous and you want to put it into decimal form, you can write it like this as well. And this is how we use the quadratic formula to solve quadratics.